Hey guys, we're going to get started. How many folks were from the workshop yesterday, the operations workshop? I see a couple. All right, so my sales pitch worked. You actually showed up for the second part. Awesome. My name is Dean Proctor. I'm a principal solutions architect with Couchbase. Going to be talking to you about monitoring today. If you did not mean to come to the monitoring presentation, there are 5 other sexier presentations out there. If you did, then you are my people. So as a solutions architect, I am very often deployed on customer sites, helping them with whatever their application requirements are, their operational requirements. Something we always touch on is how are you monitoring Couchbase? And 9 times out of 10, the answer is we're not. And for that 1 out of 10, very often the monitoring implementation isn't complete. I think this is the 4th iteration of how to monitor Couchbase that we've given at events like this. They've always been very focused on theory. My thought in this one is maybe I go a bit more concrete, give you guys a reference implementation that you can just copy, or if you're already running the tools, just go ahead and implement. And next time I'm on site, you won't be one of those 9 out of 10. So in terms of agenda, going to start with just a brief recap on some theory, the basics of monitoring, what we're trying to get out of it, go over the existing integrations or how to integrate with Couchbase if one doesn't exist for what you're using. And then we'll get into the real-time monitoring demo. And at the end, hopefully we'll have some time for questions. If not, you guys can always catch me after the session. So in terms of basics, what are we trying to do? First and foremost, we're trying to ensure the availability and performance of our clusters. More and more performance is availability, right? So if you're not hitting your SLAs, for performance, even if the system's online, it might as well be offline because you've probably already abandoned that particular operation. Second, beyond what's occurring right now, we want some system to be able to dig into 2 weeks, dig into issues that occurred 2 weeks ago, right? So we need some system that is giving us fine-grained trending of all these metrics that we're also evaluating in real time. And then finally, we want to be able to identify when we need to scale, rather than end up in a situation where, oh crap, we're out of resources and we need to do something right now, or maybe we've crossed the threshold from when it's possible to do this scaling operation safely. We want some proactive notification that you're approaching that limit. Go ahead and order some hardware. So out of those 3 objectives for monitoring, what is it that Couchbase provides? We give you 4 things, in my opinion. We give you, first and foremost, a system that hopefully is very resilient to failure in the first place. By being high availability and being a memory-first architecture, Couchbase is very resilient to spikes in throughput. It should give you those low latency operations out of the box. So at least that first set of criteria is satisfied. Beyond that, we do give you a real-time web console. So this is what you get on port 8091 when you install Couchbase. What this is a diagnostic tool. It's not intended to be your primary monitoring interface. And we'll get into a bit deeper what you get from that diagnostic tool. We give you some measure of email alerting. And then most importantly for our discussion today, we expose REST APIs for programmatically discovering what is in the cluster, as well as extracting metrics from those services. So looking at the web console, this is an example of the server tab in Couchbase. What it gives you is a listing of all the servers in the cluster, which services are running on which nodes. It gives you some basic high-level resource consumption information, along with some versions, as well as current status for any current tasks that are executing, be it warm up if you just restarted the service, or a rebalance, for example. On the bucket tab, if you click into a bucket, now there's a nice statistics button there, you're going to get some very fine-grained stats. I think on every bucket we're up to around 170 stats out of the box. And those grow every time you add a new index or add a new replication. We add additional stats for each of those. You can view those aggregated at the bucket level across all servers, where you can drill into individual servers, and then you can view those over different time ranges. The rub there is that, again, Couchbase is as it is today, is not a monitoring platform. So these metrics are heavily downsampled over time. You end up with aggregate metrics that, if you were to look at this data, say, from 2 weeks ago, it's going to be missing a lot of the peaks and the troughs, right? So if we want to really drill into what exactly happened at 12:02 last Thursday, Couchbase isn't going to be able to tell you that, at least from this interface. We also provide a set of email alerts. These are very helpful in the belt and suspenders world of monitoring. This is the belt, where if you have no other system to help you monitor your Couchbase environment, this will at least tell you when major activities have occurred, namely when nodes have failed or when you've run out of resources. But most of them are reactive, right? It can only tell you after something has occurred. They aren't proactive. They're not telling you based on some configured threshold that something might happen in the future, which isn't exactly what we want from a monitoring solution. So point of all of that is to say what you get in Couchbase is great for real-time diagnosis, but what it doesn't give you are some of those other attributes we discussed. We really want an external monitoring system paired with Couchbase to be effective. What we need from that is we need to take the Couchbase REST API so we can extract the fine-grained metrics. We need a metrics collector to do that, which is going to forward those metrics to an alerting utility and ideally also a trending utility so we can get that fine-grained history. There are a number of off-the-shelf integrations that you can use from a number of SaaS vendors as well as on-site tools. Most of these are pretty okay. None of them are complete to what I think you really need. So what I've done is I built you a new monitoring plugin for Nagios. Why Nagios? Because everywhere I go, there's always some dusty Nagios box from 10 years ago sitting in the corner. So if nothing else, we can throw some monitoring on that and at least be operational. In terms of fetching stats from Couchbase, we have 3 options. You can go to the command line and run the cbstats utility. You can scrape the stats.log file, or you can talk to the REST API. The only method of fetching stats when building one of these connectors that is going to be complete across all of the various APIs for Couchbase, be it key value or query or index or search, is that REST API. So that is how the Nagios plugin is structured. In terms of the REST API, there are a number of endpoints that we're going to hit in order to fetch all of the data we need. We're going to get some cluster configuration data. From that, we're going to discover all of the services that are available. We're then going to be fetching relevant metrics from the data service, the query service, search service, for example. All of these APIs are going to return us JSON, which we can then parse and do whatever we need to for our target system. It is worth noting that they require administrator permissions in order to interact and provide that data. On Couchbase 4, that's going to be minimally the read-only admin. On Couchbase 5, there is a data monitoring role that you'd want to assign to that user. Just some tips, and these guided how I built the example Nagios integration. The first is there tend to be 2 ways that you can extract metrics from a system. Either you can configure all of the metrics on the monitoring server side and then for each metric ping Couchbase in order to get that particular data point. For Couchbase, that's really inefficient because these stats call can be expensive. So the other way you can do it is call the server, have the server fetch all the stats for you, and then return a bulk set of stats. In Nagios terms, those are called passive checks, and that's what's been implemented in the current system. Ideally, we also want the monitoring system to discover the current configuration. It's very easy to make changes within Couchbase, adding servers, changing the services that run on the nodes, adding buckets. We don't want to also have a secondary operation where we need to then go instrument those changes in our monitoring system. So for the reference implementation, I've put a lot of work into making sure that it's doing that discovery for you and just pushing new metrics to the monitoring system, which then it can learn. So you automatically get all of that all that configured. Reference implementation is in two parts. The direct integration with Couchbase is in the Nagios plugin, which is under the Couchbase Partners account on GitHub. And then there is a complete installation that is both the Nagios server side, so getting all of that set up and configured, as well as the agent side that's going to be running on your Couchbase nodes. That's not only running that Couchbase plugin, but also capturing the set of system metrics that are relevant to Couchbase. Now, the way that it works is we first, as I said, do the cluster configuration discovery. We're going to find all the nodes, we're going to find all the services running on those nodes, we're going to find all the buckets, all the XDCR applications, and then for each of those, we're going to fetch a series of stats. In Nagios, the way it works is we evaluate the current status on the plugin side against some configured thresholds, and then we send the Nagios server some set or a value, whether that's a warning or a critical or an OK. In terms of how we do that, under the covers within the plugin, there's a series of APIs, like I mentioned. The first call that we're going to make is to this pools default API. What that does is give us this list of nodes. For each node, we get the host name. We also get the list of services. Once we have the list of nodes and the services, we then fetch the list of buckets from pools default buckets. We can then take that bucket name in order to fetch the stats. When you hit the pools default bucket stats API, you're going to get all of the stats for that bucket in a single response. We can then parse that response, look for the stats that we're interested in, evaluate their current state, and then send responses back to Nagios. There's also a tasks API that allows us to look for running XDCR replications, or if we want to monitor the status of rebalance, for example, we can get that from that endpoint. For the reference implementation, what we're doing is using that to grab the ID of your configured XDCR replications, and then feeding that into this call in order to get the individual XDCR metrics. There's also endpoints for query, which again, it's a single call, gives you all of the current query stats, as well as the search API. We can go to a single endpoint, we get all of the search API stats. Now, all told, I think I counted somewhere on the order of about 3,000 individual metrics that are being returned from all of these APIs. We're not interested in all of those from an availability monitoring standpoint. There's really only about 25 or 30 that matter, and those I have encapsulated in the reference configuration. Now, in terms of real-time monitoring, well, there's two types of monitoring that we could be doing, right? We're doing real-time monitoring, then we're doing trended monitoring. What Nagios provides is real-time monitoring. Is something down? What is the current state of my cluster? You then have the trended monitoring that tells us over time, how has my installation changed? So primarily what this plugin is doing is giving you the real-time monitoring. What we care about there is to make sure that everything's online, that all of the resource usage is within the expected safe levels. We're trying to determine if there are any metrics that are trending in a bad direction, right? So they're going over, say, a warning threshold. And then finally, we're evaluating the current response times. In addition to the Couchbase metrics, we're also going to be evaluating a series of OS metrics. This plugin, we're not trying to solve all the world's problems with it. It's just looking at the Couchbase APIs. Then there's going to be, in the reference implementation, a separate set of commands that are executing to pull back OS metrics that matter. Those are what's listed on the screen here. Essentially, everything that you're probably already monitoring from an infrastructure standpoint. And now let's look at the implementation. So as I mentioned, it's broken into two repos. We have the full reference implementation, which gives you a set of Docker images. We have a Nagios image there that gives you the server side of the equation. And then we have NRPE, that's the Nagios remote plugin executor. That is what's running on the Couchbase host itself that runs all of the data collection for system metrics as well as executes that Couchbase Nagios plugin. separate repo for the Nagios plugin itself, and it's pretty simple. There's a Python script that actually interacts with the Couchbase API, and then there's a configuration script, or a configuration file. What you guys care about is the configuration file. There's only a few things that you need to change to hook this up to your environment. The first is the Couchbase host. If you're running this via NRPE or via some sort of local agent, you can just always configure that to talk to localhost. You need to configure your user that you want to authenticate against those APIs. You can choose whether or not you want this communication to be done over SSL or not. Beyond that, there are two options in terms of extracting metrics for where we want to send those. By default, it's into Nagios, but there is also support for Graphite if you want to have those metrics trended, which I do recommend. And then finally, we get down to all of the metrics. These are divided into different services. So we have data service metrics, we have query service, we have full text search, we have XDCR. In addition, we have some computed node metrics. Each of these metrics are configured by passing the Couchbase REST API name for that metric that we're interested in. We have a pretty description so that whoever is getting these pages at 3 a.m. knows what that name means. And it's at this point that we are setting our thresholds. The thresholds that I'm setting, some of them make sense given Couchbase's architecture. A lot of them, especially the throughput metrics, the latency metrics, they're very much going to be dependent on your particular implementation. So the recommendation there is go ahead and run it with defaults and then adjust those default thresholds based on what makes sense for your environment. My recommendation is you baseline that environment and then set your thresholds to be about 20% beyond that baseline. Once you have that hooked up and you're running the Couchbase Nagios Docker container, what you're going to get is Couchbase running. You're going to have Nagios running on port 8080. Within Nagios, and there are instructions in the Docker container, all you're going to do is give the plugin a list of hosts. For each host, you're going to tell it what services are running. All that does is inform the OS metrics that we're going to try to collect, make sure we're pinging all the right ports, that we're looking at all the right processes, and then the plugin does all the rest. It then uses all that discovery we talked about to configure a whole bunch of services automatically. This, for example, is a 6-node cluster, and from that 6-node cluster, it has 381 metrics that it's pulling back across all the buckets that are configured, all the XDCR configurations, all the different services. For each of those services that it's evaluating, some of them have a status. You can see my cluster, I'm running a load test against it. According to the defaults I have set, it's not a happy cluster. In reality, it's just because I'm running a load test and my defaults are rather conservative, right? So if I were expected to get 45,000 gets per second in reality, I probably would want to bump up my thresholds. As I mentioned, there's also a Grafana output for this plugin, or a Graphite plugin, and Grafana being the dashboarding utility, so I can get trends for all of this data. I can look at what the current value is I'm getting out of Nagios. I can compare that to the trended value and understand whether or not what I'm seeing is normal or if it's outside of a normal range. And with that, I'm going to open it up for some questions. In the back. Sorry, we're going to have some microphones coming around. If you could please use the microphone, that'd be great.
Do you have the Grafana dashboard available somewhere?
It will be. Yeah, that's work in progress. Nagios is baked. Grafana is a work in progress.
Yeah. So eventually, the metrics will send to both applications of Nagios or Grafana, right?
Yep.
So but right now, it's only Nagios.
It'll do both.
It'll do both.
It'll do both today.
On the configuration file, or?
In the configuration file, you choose which output you want, whether it be Nagios or Graphite.
So I want both, can I do?
Right now, it does either or, so if you want both, you just run it twice.
Okay, good, thanks.
Yeah. More questions?
what if that node goes down?
If the node that I have configured here goes down, this is, the way it's configured is we have an agent run on every Couchbase server, right? And the agent is calling this plugin that is only looking at the local stats. So a single node can go down, that's fine. We're gonna stop getting stats from it, and Nagios is going to throw an alert because of that. Other servers will also note that there's a bad state within the cluster and report that.
What about the graphite?
There's not much I can do for giving you high availability monitoring. That's on you. All right, any other questions? Great. So just to sum up, this is great. If you have no other existing implementation, take a look at the Nagios implementation. It'll give you some monitoring out of the box. If you want to do your own bespoke implementation, take a look at that Python script. It gives you a pattern to follow for how to interact with Couchbase. And then finally, and most importantly, are going to be the set of metrics that matter. Again, out of the 4,000 or however many Couchbase is returning, there are only about 20 or 30 that are configured here. And these are the ones that I do recommend that minimally you plug into your system.
Is there a library of explanations of those 4,000 metrics?
There are, and in the documentation I am sending, there's documentation links in the comments. Anything else? Beautiful. All right, thanks guys. Next session starts in this room when?
Well, it's supposed to be Ketaki Gangal too. Is Ketaki here?
Okay. Thanks everybody.